All right, this lesson we are going to be using our graphing calculators to help us solve some kind of complicated problems that we are not able to solve algebraically. So the first thing that I want you to do is, wow, this got kind of crazy, is to put your calculators in radian mode and to set your window um, according to this. So you're going to press the mode key on your graphing calculators, and then this is how I want you to set your y min and your y max and all of that good stuff. So I will help you do that here. We are going to go to our graphing calculators. I'm going to press mode right now, and I want to make sure that my calculator is in radian mode. So I'm going to hit radian, or highlight radian, and hit enter. And then I am going to go up top here to my window key, and I'm going to have you set your x min at negative pi over 8. So negative pi over 8 divided by 8. When you hit enter, it's going to change to a decimal, just so you know. So hit enter. I want you to put your x max at 2 pi. Hit enter. I want you to put your x scale at, it should be positive pi over 4, not negative pi over 4. So positive pi over 4. Okay. And then your x min at negative 5, your x max at 5, and your y min at negative 5, your y max at 5, and your y scale at 1. Okay, so that's how your window should be set. So go back and double check that if you need to. So we're there, and we're going to use this for our next problem here. Okay, so first of all, it says to solve 5 sine at theta plus theta equals 3. I'm going to show you a couple of different ways to do it. One of them is to use intersection points, and the other way is to use zeros. Most of you will do the zeros way, but I'm going to just quickly show you the intersection points. When you use the intersection points, what you're going to do is you're going to take the left half of the equation, the 5 sine theta plus theta, this part of it here, and you're going to put that into your y1, okay? And then you're going to put the right equation, this part, into y2 when you're doing it using intersection points, okay? So 5 sine theta plus theta goes into y1, and then 3 goes into y2. So I'm going to go up here, and I am going to go, and actually, you know what? I'm going to have you turn your stat plots off just to make sure. So I want you to go second, y equals, number 4, enter before we do anything, and you should not have to do that again. So second y equals number 4, enter, and then do that. Okay, so here we go. Now we're going back to y equals. We're going to put 5 sine theta, and you have to use the x for the theta key, so you're going to use x, 5 sine theta plus theta, or x in this case. That's going to go into your y1. Hit enter, and then in your y2 you're going to hit 3. Okay? And then I want you to hit graph. And we are only worrying about values between 0 and 2 pi. When we do it the first way using intersection points, your answers are all the places where your two lines on your graph intersect. So there would be a spot right here, and a spot right here where my cursor is moving around, and a spot right here where my cursor is moving around. Okay? And to figure out that point, you're going to use a function on your calculator called intersection. So you're going to go second trace, which gives you the calculate, and then you're going to use intersection, which is number 5. So I'm going to choose number 5. Notice my calculator is asking me for a first curve. So first curve, hit enter. Second curve, hit enter. And then I guess you're going to scroll your cursor to as close to that intersection point as you can get. So I'm going to put it right about there, and I'm going to hit enter. So that spot is about 3.18. Why don't you give me 2 decimal places? That would be great. Okay? That spot is the coordinate 3.18. Okay? And then I will kind of move my cursor a little bit, and I will do it again. Okay? So I'm just moving my cursor. All right? And I'm going to go second trace. Number 5 for intersect. I'm going to move my cursor here so that it just shows up in a little bit of a different spot. So now it's asking me for a first curve down here, hit enter. Second curve, hit enter. And then scroll it to as close to right on an intersection point as you can get it. So I'm going to put it right here. It's asking me for a guess. I hit enter. And that intersection point would be 0.519. Okay, and then you would repeat that process a third time for the third point over here. Okay, so that's one way to do it. Probably not the way most of you are going to do it. Okay, but that is one way to do it. Another way to do it in part B would be to have the equation set equal to 0. Okay, so if I take this equation and set it equal to 0, I am going to subtract 3 from both sides, obviously, and from that one they drop. And then I will have the equation 5 sine theta plus theta minus 3 equals 0. Okay? When I do that, then I have it set equal to 0, and that's probably what most of you will do. Then what you're going to do is you're going to go to, and when you do it this way, you're going to go to your calculator again, and you're going to put, you don't have things in y1 and y2, only in y1. So go up to your y equals key. I'm going to clear out my y2, and then I'm going to go back up to my y1. And remember that my equation then became 5 sine theta plus theta, and I have to use the x's for theta, and then minus 3. And I'm going to hit graph. And now you'll notice your graph looks a little different. When you have set your equation equal to 0, your solutions are all the spots where it crosses the x-axis in that window. So in this case, there are 3 spots where it crosses the x-axis in that window. Sometimes there won't be any spots in the window that it gives you. Sometimes there'll be 1 spot, 2 spots, 8 spots. It doesn't matter. But your answers are all the spots where it crosses the y-axis or the x-axis. Okay? When you've done it this way, then you're going to go second trace again, and you're going to use number 2, which is 0, and I know you did this back in Algebra 2, so this should not be familiar, or should be familiar to you. I'm going to find this far left point over here first where my cursor is moving, and so I am going to use my cursor. Notice it's asking me for left bound. That means your cursor needs to be a little bit left of that spot where it crosses the x-axis. So I'm going to move my cursor right here so that it's a little bit left and hit enter. Now notice it's asking me for right bound, so I'm going to go a little bit right and hit enter. And then I'm going to put it right on that intersection point and hit enter. So my first answer is 0.519 again. Okay? I'll repeat that process. Second trace, number 2, and then I will scroll a little bit left of that intersection point, hit enter, a little bit right of that intersection point, hit enter, right on that intersection point, hit enter, and your next answer is 3.17. So you should have 2 answers so far, and they are 0.519 and 3.177, and then we'll repeat that process one more time and go second trace, number 2 for 0. This time I'm going to use the far intersection point, so I want it a little bit left of this far right point over here. Let's see, hit enter, a little bit right of it, hit enter, right on it, hit enter, and then your last answer should be 5.71. Okay, so either way you do this problem, you have 3 answers. Whichever way you choose to do it is kind of up to you. But your 3 answers should be 0.519 and 3.177 and 5.71. Okay, and those are the 3 answers to that problem. All right, now moving on to a story problem, now that we kind of know how to do that. It's talking about a rain gutter that's needing to be constructed out of aluminum sheets that are 12 inches wide, and you mark off a length of 4 inches from each edge, and then you bend that angle up to form an angle theta. And you want to maximize the area of that opening, okay? So it gives you an equation. Notice what I want you to notice is that to the right of this, it gives you a restriction. This helps you kind of set your calculator screen, okay? It gives you a restriction on that equation. Notice that it's in degrees. It's 0 degrees to 90 degrees. So what you're going to use is you're going to use that information to set your window. You're going to go back to your calculator screen. Because it's talking about theta in degrees, I need to change the mode of my calculator to degree mode instead of radian mode. So I'm going to go to degree mode and hit enter. Okay, then I'm going to go to my window and I'm going to put my x min at 0 and my x max at 90 because it tells me that's my theta has to be between 0 and 90. And if I'm going from 0 to 90 and I need to kind of go in even increments, 10 is probably a good increment. I'm going to leave my y scale for right now. We'll talk about that in a minute, okay? But I'm going to leave that. So I've got my window set now. And now I'm going to go up to my y equals. And I am going to put this equation in there, 16 sine theta. So I'm going to clear this out. 16 sine theta, and again you have to use x, and then close your parentheses, times cosine theta, close your theta, plus 1. And I believe that that's how the equation goes. Okay, and then you're going to hit graph. And you kind of get a hot mess here is what it looks like. But the question on this particular problem is, what is the angle that maximizes? Notice that's in green, that maximizes this area. When it's asking you what angle maximizes it, you want to find the maximum on the graph. The problem is I can't see the maximum on my graph right now. So I need to go to my window and I need to be able to change how high my graph goes. And when I change how high my graph goes, that means I'm changing my y max. And I don't know what I need to change it to. I am totally guessing. I'm going to start with 50. And if I'm going on my y scale from -5 up to 50, I probably want to go up by 5. So let's try that. Okay, and now if I hit graph, the question is, can I see that high point on the graph? And I can. I can see the high point, so that's very good. Okay, to find that high point, you're going to go second, trace. You want to do maximum for number 4. Notice it's asking me for the left bound, so I want to put my cursor a little bit left of that high point and hit enter. And then I'm going to put my cursor a little bit right of that high point and hit enter. And then it's asking me for a guess, so I will put it right on that high point or so, as close as I can get it, and hit enter. And so the maximum area is when the angle is 60 degrees, when theta is 60 degrees, or x is 60 degrees. That means your maximum area is your y, which is 20.78, and I don't even, did it give you inches? Square inches, I believe. I believe is what it gave you for a unit is inches, okay? So your angle, your maximum area is when your angle is 60 degrees, that's the x part, and your area is 20.78 square inches, okay? So graph the above to find the angle that maximizes the above. It maximizes it when theta is 60 degrees, okay? All right, then it talks about how in calculus you will have to find, one way you'll find that angle that maximizes the area is by solving this equation. Notice it says to solve it, not to maximize it, but to solve it, okay? Your window will be the same because you're still between 0 and 90, so I don't need to worry about that. I am going to set this, pretend that it is set equal to 0. Okay, so I'm going to take this equation and I am going to put it into my y equals, again, cosine 2 theta plus theta. So here we go, y equals, I'm going to clear this out, cosine 2 theta plus theta, or x in this case. I will hit graph. Maybe. Oops, I messed that up. It's cosine 2 theta plus cosine theta, so I have to go change this. Cosine 2 theta plus cosine theta. Okay, now hit graph. Now let's try this. Okay, now what I care about here is solving this equation or figuring out where it crosses the y-axis. So I'm going to go back and change my window so that my y max again is a 5. And if I'm going from -5 to 5 on my y-axis, I'm going to change that scale to a 1. And I'll re-hit graph again. Notice in this case that there is only one spot in the allotted window where that graph crosses the or x-axis. So there's only one answer in this case. And so I'm going to find that answer by doing second trace. And I am going to do number 5 for intersect. Hit first curve, enter. No, I don't want to do number 5. I'm going to start this over. Second trace. Number 2, zeros. Sorry. Left bound. So I want my cursor a little bit left of the intersection point. Hit enter. A little bit right of the intersection point. Hit enter. And right on the intersection point. Hit enter. And again, I will get 60 degrees. Okay? So that should do it for you.